Hello and welcome to SSC classes. Today we are going to solve some questions based on quantitative aptitude. As we know that quants is one of the most important portion in any competitive examination, and it is the most scoring portion also, as it requires only your basic numerical and mathematical skills. So if your mathematical skills like from class 6 to class 10 are clear, then you can easily get a good marks in this portion. Okay. So let's start with the first problem. The base of a right prism is an equilateral triangle of area 173 centimeter square and the volume of the prism is 10,380 centimeter cube. Now the area of the lateral surface of the prism, we need to find the area of the lateral surface of the prism. Okay. Now as we know that volume of prism is equals to area of base into height. Volume of prism is equals to area of base into height. Okay, now the area of base is 173 centimeter square. We do not know the height, let it is h, and the volume is 10,380 centimeter cube. Therefore the value of h is 10,380 whole divided by 173, and this is equals to 60 centimeter. Okay, now area of the equilateral triangle is 173 centimeter square. Area of the equilateral triangle is equals to 173 centimeter square and root over 3 by 4. So we can say that root over 3 by 4 side square, which is the area of an equilateral triangle, is equals to 173 centimeter square. So from this equation we can find the value of side of this equilateral triangle, which is nothing but side square equals to 173 into 4 divided by root over 3, and side is equals to root over 173 into 4 divided by root over 3. Okay, now as we know that the value of root over 3 is 1.73, so it reduces to root over 400, which is nothing but 20. Therefore the perimeter of the equilateral triangle is meter of the triangle is 20 into 3 centimeter, which is nothing but 60 centimeter. Hence the lateral surface area of the prism hence the lateral surface area of the prism is equals to perimeter of the base into height. Okay, now the perimeter of base is 60 centimeter and we have the height also as 60 centimeter. Therefore our required surface area is 3600 centimeter square. Hence, option C is the correct answer. Now let's check the next question. If a right circular cone is separated into solids of volumes V1, V2, V3 by two planes parallel to the base which also trisect the altitude, then we need to find the ratio of V1, V2 and V3. Okay, so first of all we draw the diagram which helps us to solve this problem. Suppose this is the big cone and the cone is separated into three areas parallel to its base. Okay, now this is the height of the cone and this is the radius of the base. Now we named this cone. Suppose it is PST. These 2 points are R and U, and here we have Q and V, and these points named as A, B, and this is O. And the height of the big cone is H. Now suppose that PST be our right circular cone with radius R and height H. With height H and radius R. Therefore, the volume of the right circular cone is the volume of right circular cone is 1/3 pi r square H. Now, when right circular cone is divided into three parts, then AP is equals to AB is equals to OB. When right circular cone is divided into three parts, then AP is equals to AB is equals to OB, and this is nothing but H by 3. Now we have two similar triangles APQ and OPS. Okay. APQ and OPS. Therefore, the angles PQA and PSO are same. PQA is equals to angle PSO and Also, angle PAQ is equals to angle POS, that is this angle PQA and PSO and PAQ and POS, where PAQ and POS both are 90 degree. So we can say that AQ divided by OS is equals to PA divided by PO, which implies AQ is equals to PA into OS divided by PO, or we can say that AQ is equals to H by 3 into R divided by H, which is nothing but R by 3. Now in the similar way, in similar triangle PBR and POS, PBR and POS means the big triangle. Angle PRB is equals to angle PRB is equals to angle PSO, and angle PBR is equals to angle POS, and from this we can say that RB divided by OS is equals to PB divided by PO, and this implies that RB is equals to PB into OS divided by PO. Okay, so from this we get 2H by 3 into R by H, which implies 2R by 3. Now the volume of the upper part is the volume of the upper part is 1/3 of pi r squared, that means r by 3 whole square, into h by 3, which is nothing but pi r square h divided by 81. Now the volume of the right circular cone PQRUV is equals to, suppose this is the equation 1. Now the volume of the right circular cone PQRUV is equals to 1/3 of pi 2r by 3 whole square into 2h by 3, and this is equals to 8 pi r square h divided by 81. Therefore the volume of the middle part is equals to volume of the middle part is equals to 8 pi r square h divided by 81 minus pi r square h divided by 81, and this implies 7 pi r square h divided by 81. So the volume of the lower part is equals to volume of whole right circular cone minus volume of PQRUV. So volume of lower part is equals to volume of whole right circular cone minus volume of PQRUV. Okay. Now the volume of the whole right circular cone is 1/3 pi r square h, and volume of PQRUV we already get 8 pi r square h divided by 3, sorry 81. Hence from this we get pi r square h 1 by 3 minus 8 by 81, or 19 by 81. So suppose this is equation 3 and 7 pi r square h is our equation 2. So from equation 1, 2 and 3 we get our required ratio. Which is nothing but pi r square h divided by 81 is to 7 pi r square h divided by 81 is to 19 pi r square h divided by 81. So it reduces to 1:7:19. Okay, so D is our correct answer. So we have successfully solved two questions based on geometry. Basically they are from quantitative aptitude, but particularly the questions are from geometry. Okay, so that's all for today. So if you want to know more about quantitative aptitude, then you can join our classes. So feel free to contact us in these two numbers 9836793076 or 9874822756. And for further details, you also can check our website, which is www.swordofsuccessclasses.com. Thank you very much.